ways to do pointers to pointers. So we did an allocation of 30 ints, and then we did a separate allocation of 4 pointers, and we made those 4 pointers point to those 30 ints. And we don't have to.
The int star times 4, is that just saying like the size of the pointer times int?
Exactly
Okay.
right. We can have any type here because all pointers are 8 bytes, so that's always going to return 32 bytes. So I'm going to flip this upside. I'm going to flip it around, and let's do int array 2.c. And so this is what we have right now, where we allocated 30 integers and then we have offsets in those 30 integers. But I'm going to now do it differently, where I'm going to allocate starting oops. Ha.
Is it still broken in this chair?
No, go for it.
Okay, thanks.
We're taking a video right now though, so just we're going to keep going. We're going to start by allocating these 4 pointers, but now we're going to have each of these pointers get, instead of having one big contiguous array of ints, we're going to have 4 separate arrays, and that'd be totally fine. It's just a different decision. So we're going to say, we're going to start by saying this, and now there's no x to point to, but I'm going to say that I want y0 to point at its own 4 integers, and y1, 2, and 3 to do the same. And now these will be different locations. You know, maybe this one points at, I don't know, 2060, and this one, like if you tried to reason about it, say, oh, maybe it's 16 bytes forward to be 2070, but maybe, you know, maybe it was 90 for whatever reason, for however it's working. And, you know, and this one, maybe it's something sooner. Maybe it got 2030, and maybe this one got 2040. And so what this would mean then is we now have a really different setup where in memory, you know, we've got 0x2000, we'd have 32 bytes here to store 4 pointers. So let me just write those out. It'd be 2000 and 2008. And then, you know, we could keep going in memory. So there's 20 and 28. And then 30 and 40. And then in this case, 2000 would have its address, I'm sorry, Y3 2018 would have its address, its value being 020. And this one would be 2030 and so on. And so now we've got 4 bytes, 4 ints here, we've got 4 ints there, and this is the one that we would think as being Y2, and this one is Y3, and based on these addresses, Y0 and Y1 would be down below. And so this is a different thing, which is where in the previous example we had 30 ints. This is looking at getting, let's see, did I get that wrong? 1, 2, 3. 1, 2, 3. Yeah. So now this is 4 ints, and so we've got 4 ints, and somewhere else we've got another 4 ints, and somewhere else we've got another 4 ints, and they're just kind of separated in memory. So they're not consecutive memory addresses like we had up here where we had 30 in a row. We just made 4 different allocations, and our 4 pointers are pointing to 4 distinct allocations, where before they pointed to like sub-locations within an array. Both totally valid. 2 different decisions about how to do pointers to pointers. Okay, I'm going to stop this one now.